you need to turn to page, I don't know, 19, I guess. Page 19, we need to talk about polygons. Yay, polygons. Polygons are shapes. Yeah. So specifically, a polygon is a closed figure formed by a finite number of segments.
What? You segments?
Segments.
The figure is. Oh.
Okay, so the edges are what we say the sides are. And these corner points where the segments meet, that's what we consider to be the plural vertices, but one vertex is where two sides meet. Okay. Yeah. Finite means we can put a number on it. It's not infinite. So we can always count the number. We can always count the number. Both of these two pictures are polygons. Tyler.
So if like a shape is not closed off, it's not a polygon.
Correct. Correct. And we can count the sides. Okay. Yes.
So a circle is closed off, but it's not a polygon because it doesn't have any sides.
Has one side.
Yeah, you consider it for one side.
Technically, we can say it's a polygon.
So whatever.
I don't like it, but it's a closed shape.
Any shape.
So is it close
Any
figure
color.
formed by a number of
Segments. Yeah. So like, take a bunch of segments, let their endpoints meet. We have a polygon. Okay.
What happens if they overlap? Like what happens if one side like goes far? Like if you see on the vertex, if that line just kept going.
Then that's not okay.
Okay.
Closed figure. Closed.
Would still be close.
Yeah,
Like, but
it's
just
like
that part of
It's
it.
a point opening up, so.
So that wouldn't be considered part of the polygon.
So it still would be a polygon. but-
So like this part would be, but that part wouldn't be. Okay.
Can a polygon be considered a quadrilateral?
That a quadrilateral is a type of polygon. Let's talk about those types. I think I would. If we have three sides, we call it a
Triangle.
triangle. Okay, Cohen just asked this question. 4 sides. A parallelogram is a, no, I don't know why you're laughing because he's not wrong. A parallelogram is a special type of quadrilateral. And we will have an entire chapter on quadrilaterals in which we will talk about parallelograms and trapezoids and rhombus and, oh, just a joy. Okay, what about 5? Pentagon. You know, there's a building that's named the Pentagon because it's a pentagon. Okay. 6 sides. Hexagon.
Is that what we call like pentas? Because there's 5.
Yep. It's not 7-agon. No,
No?
heptagon.
Wait, so it's just. Well, because hexagon would be, because normally it's SEX, so it's instead of SEX.
I only know that.
Okay, hey, well, like, we're not talking. Okay, 8 is an octagon. A stop sign is an octagon. You're gonna love this. Nonagon.
We learned about this a long time ago.
No, I did not learn about this ever.
In like fourth grade. We learned about all like that.
Pentagon.
Do you wanna turn here? Turn on? Are you gonna like? No.
No?
No, you can work on that in Flex.
What if you don't have Flex?
Can you work on it at home?
What page is this on?
14. All right. And then 12. Riley told me this one. Dodecagon. We would just call it an 11-gon because anything else is just an n-gon. And really, who wants a polygon with 11 sides? Dodecagon. Yeah, we're not gonna worry about 3D quite yet. We're still gonna stay in 2D. Okay.
Any above 12.
Okay. No. So here's the deal. If you see something in your notes that says n-gon, that means it's a polygon with n sides. Okay. Okay, now I want to look at the pictures that I drew, which by the way are beautiful. And I want you to silently think about the words concave versus convex. Just one of these two. Silently means nothing to you all, does it? One of these is concave and one of these is convex. So just silently think about which one is which. Okay. Turn to your neighbor and whisper which one you think Okay, so raise your hand if you think that this is concave. Convex. Concave. Okay, so a convex polygon means you can connect two corners and the line stays inside the polygon. Okay, I can connect any two corners and my line is inside. Versus a concave, if I connect these two right here, I'm not inside the polygon. Okay, another way I like to like concave, like it's caved in.
Yeah, it's how I
Well, good job. See, we have the same wavelengths. Okay. This is very not official, but just to help you, it's caved in. Okay. All right. So I want to just draw your attention to this cute little picture right here. Okay. A polygon is a closed figure formed by 3 or more line segments called sides. Okay. I'm going to take this back. A circle is not a polygon because it doesn't have segments for sides, but a circle is a closed figure, but it's not a polygon. I don't know. Circle. Circle's a circle. A circle is a conic section, which you'll learn all about in pre-calculus. Okay. The sides. The segments are called sides. And where two segments intersect, where two sides intersect, we have a vertex. So notice how this, we say this is vertex D, because that's the corner and we named it D. It's a point, okay? This side is segment BC. So go ahead and highlight side BC, vertex D. When you talk about a polygon, you're gonna name a line segment for the side and a point for the vertex. Now notice how I named a line segment and not a line, okay? I will be very picky. Listen to me. I will be very picky if I want a line and you give me a segment, or if I want a segment and you give me a line. The arrows do make a difference. Does it stop? Does it keep going? Okay. Now, if you want to name a polygon, you take all of the vertices and name it polygon A, B, C, D, E. Or if there's like 4 vertices, you would name polygon bum, 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 bum. Okay.
If it was like 26 vertexes.
Yeah.
That'd be 50.
Guess what? I'm not going to give you one. Colton.
Yeah.
If there was one that had like 27, would you have to repeat it in the letters?
You'd call it like double A, maybe. I'd have to think about it. Okay, so in your head, that means no noise. Think about, are these polygons concave or convex? Just think about it, think about it, think about it.
Think about it.
Okay, Drew, what's the green one? Concave. Yes, it is.
No, you connect, wait, I have a question.
It's caving in. Also, if I connect these 2 corners, does that line stay in the inside?
No.
Nope, it's concave.
Oh, I thought convex was out. Oh my god. No, it's like, wait.
Okay.
I'm not confused with
Zach, which one's the red one? Thanks, Zach.
Oh, sorry. Well, I
It's
just
okay.
wanted to get extra practice.
No. All right. Now, I am hoping that this is just a reminder. If I ask you for the perimeter of a polygon, you are going to add up the sides together. If I ask you for the area of a polygon, right now, you only know area for triangles and rectangles. Okay, so rectangle length times width, triangle or base times height, triangle 1/2 base times height. Okay, in your homework today, you are going to get some polygons, really triangles and rectangles, in the coordinate plane. So we are going to do 2 examples in our last 15 minutes together here, right? I have you until 28. JK 24 in our last 11 minutes. So you are going to need to put this in your notebook because I don't think it's going to fit in that little space you have. Yeah.
And it's only with paper.
No. Well, but you get a skip.
Wait, what's?
I don't think you have small enough handwriting, Colin. I don't think you have small enough handwriting.
I'm confused. What are we practicing?
Okay. I really appreciate those of you who are quietly getting out your notebook. Your homework are the next 2 pages of your journal. So like turning the page to put this example in isn't gonna work because that's where your homework is. Okay. So here is our problem. I want to know the perimeter of this triangle if the vertices are these 3. So what I would like you to do is write down that we have these 3 vertices. Okay. I would also like you to draw the graph. I really like what Cohen did to draw his graph. He made the x-axis, he made the y-axis, he made the triangle. And then he's just gonna label the points. It's gonna be fine if you're like Cohen, okay? You don't need to be super exact. You're definitely gonna want a calculator when you do your homework. If you don't own one still, you can use one online somewhere. If you're doing it at home or in Flex. So Desmos is a good place to go, the Desmos calculator. Okay. Yep. What does?
I had to use that last year.
Okay. Your discussions are leading me to believe that you're done with this picture. Hold up one finger if you need more time to draw. You need more time to draw? You need more time to draw? Okay, you get 30 seconds. Well, we're going to, but I'm waiting for everybody to draw it.
I don't know how to do it.
Is the final perimeter, is it A squared, B squared, C squared, or is that a little different?
Well, that would be like for one side. Yeah. Oh. Okay, so we're gonna go ahead and talk about this problem. Yeah. Okay, you are doing this with me. You are doing this with me. Let's talk about the distance it is from A to C. That's this guy right here. Okay. Do you think we can calculate that distance right there? Okay, you can do one of two things. You can count, or you can say, okay, I'm taking 3 minus a -3 and it's a distance, so it's an absolute value. Okay. 6. Cool. Let's talk about the distance of this guy right here. What is the length of segment BC? You can do one of two things, especially if you're on a grid. You can count 1, 2, 3, 4, 5, or we know that the x's are changing, so we can take 3 minus -2 to get our distance of 5. Okay. Okay. What about AB? Oh, what'd you say? We have this cool thing called the distance formula.
Maybe just the same thing.
What? Now, some of you who were not patient enough to wait for me started to do the Pythagorean theorem. Do you remember when I told you that the distance formula is the Pythagorean theorem? Yeah, so it's fine if you do that. Okay, I'm going to do the distance formula because I think we need to revisit it. Okay. AB is the square root of x minus x. So I'm going to take 3 minus -2 squared minus plus, excuse me, y minus y. So -3 minus 3, the quantity squared. So we have 5 squared plus -6 squared. My precious geometry students, you are better than to tell me that -6 squared is -36. If the negative is in the parentheses with the square, a negative number squared is positive. I had a good handful of people make that mistake. That's why I pointed out. So this is the square root of 61. What? 7.8. Thank you. So our perimeter is 6 plus 5 plus 7.8, which Carson has given us the final answer. Oh, I thought you had it all done for me.
1840, or yeah, 1840.
18.8? Do we agree with that? You're not sure?
So AC plus DC plus 6.
So like I added all the sides together to get the perimeter. Yeah.
It's just finding A to C is. I was wondering how to find that, like the one side.
Oh, it's positive, that's right.
Okay. Now I have a question. What if I wanted the area of this triangle also? We know that it's 1/2 base times height. Don't answer this right now. Do we know the base? Do we know the height lengths?
Yes, we yes.
Okay, Addie, what would be considered the base? CB. Segment CB is our base. And AC is our height. So we can say 1/2 times 6 times 5 is 15. Oh, and Mrs. Homan. We need to say that this is 18.8 units for perimeter. For area, we would have units squared. Yeah. Who had a question for me about that 15?
Did you like multiply 6 and 5 in 1/2?
Yeah.
Yeah, or you can say 1/2 times 6 is 3 times 5 is 15. Whatever order works just fine. Okay. Now, I am a little bit worried about one question on the homework. So let me just like do a little bit of thinking ahead. You don't need to write this down because I don't think we're going to have time. But if this is what your triangle looks like, this is the base. And these two sides are not the height. The height needs to be perpendicular, okay? So from this vertex, we can draw this 90-degree segment. That's the height. So here's the base, here's the height. Okay, on your gold sheet, it says to do the student journal page, but I'm fairly certain you can skip 2 of the problems. I just don't remember which 2. So please reference your gold sheet so you know which 2 problems not to do. Will I post the answer key?
Yes.
Do I expect you to check your answers?
7 and 8. Skip those.
Oh, 7 and 8. Skip 7 and 8.